wanted to start by echoing what Bernie just said about the celebration on Sunday night. And Susan, you know, thank you so much. It was unbelievably amazing. And it just, you know, as I was listening to that and also thinking about our work here and what we've been able to accomplish in this valley, it just really hit home, you know, the community that we have here in Jackson Hole and the community that Bert helped build, and that, you know, many of you on this call are helping to continue. And, you know, I was thinking about that also as I was building out this presentation, and really, you know, what hit me was the importance of this collaboration as a community we have, and the values that we hold as this community. For whoever you work for and whatever you do, we all have a love of nature, and being able to showcase that and use that in a way that's advantageous for the birds and for people is really what this presentation is about. And that's really what I want to showcase, is that, you know, it takes a village, and we have this amazing village. And, you know, we just happen to, you know, I happen to be lucky enough to be involved in one of these projects. But, you know, the best we can all do is you know, to uphold Bert's legacy, is to continue that value of community and value of nature, and do what we can to work together. So to that end, today, I'm going to talk about a project that we've been working on for a number of years in collaboration with Brieger Teton National Forest. And I'm just going to start off by saying I am not a forestry person. I am not a fire ecology person. I am a bird person. So it's going to be geared towards birds, and I may screw up when I talk about some of the fire stuff. So please forgive me on that end. But I think we'll all kind of get the gist of it. So I have, let's see if I can figure out how to move slides here. I have the privilege essentially to be the mouthpiece of this, this project today. I don't want to be considered, you know, the lead on this. I think we have some amazing folks that have worked together, both from Brieger Teton National Forest as well as Teton Raptor Center. I'm going to absolutely throw Susan into that mix too. I think without her and her guidance over the years, a lot of this stuff that I'm going to be talking about wouldn't exist. But special shout out to Andy Hall, Jason, Carrie, Andy Norman, Randy, and Terry from Brieger Teton, because really this was done in a true collaboration with Brieger Teton, and wouldn't be happening without the dialogue that we have ongoing. And then just the whole host of folks that have helped out in the field. You'll see this is a ridiculous amount of work that's gone into this, and so many folks have been helping out, including others not on that list that are even just getting started this week. So what we're going to be talking about today is related to the Teton-to-Snake fuels reduction project. And so that's a project that, you know, from my understanding, was spurred by the Green Knallfire in 2001. And really, you know, that showcased to the community of like, hey, there's a pretty significant risk along the wildlife urban interface along the west side of the valley, you know, from Teton Village all the way down to the Snake River corridor. And so as a result of the Green Knallfire in 2001, Forest Service identified the increasing need to reduce those fuel loads across the forest lands right next to our urban interface and some of our neighborhoods. And so they started thinking about this and working through this, you know, in the, you know, mid, you know, 2000, I'm not even sure really when it started, but I imagine somewhere, you know, around 2005, 2010, and then really got legs and rolling around 2013. And it took several years for that process and the EIS process to go through before the final environmental impact statement was released in 2017. So I'm going to talk a little bit about that history, and then, but on the right depicts just the general broad treatment areas. And I'm just going to put the caveat on that some of my maps are not up to date as far as those boundaries go, but I'll give you a general sense of what's going on. And a lot of this is predicated upon where wilderness areas are and making sure that those treatments are outside of wilderness areas. And then the blue areas are the mechanical, and the fire is in the red. But we'll talk about more of that in the details. But I'm going to start, around that same time. Susan Patla, Catherine Gura, and I were kind of throwing around the idea of what we need to do with great gray owls, and the fact that we didn't really know much about great gray owls. And so we secured a state wildlife grant to begin studying great grays in the valley in 2013 as a 3-year project. And so what we were really looking for was, basically just understanding the biology and demographics of that species as they occur at kind of the southern terminus of their range in the Rocky Mountains. And there have been some previous studies done here, which gave us a good baseline, but we were looking at things like productivity, survival, movements, habitat use, seeing if we could predict out nest sites and nest site selection and things like that. And so this was ongoing, we were just getting this started, and I was just hearing about this kind of nebulous Teton-to-Snake project, but, it got me thinking of like, hey, how do we potentially, merge these two things? We've got a big forest treatment that's going on that is probably going to happen. We've got a new project on great grays. So, let's think about how we can maximize our effectiveness and merge these two things. So without really, at this point, I didn't know really much about Teton-to-Snake other than I knew that it was a possibility. I probably had the same thought process that a lot of folks did around town of like, oh my gosh, forest treatments, they're going to clear cut the forest. I was like, I better get in there and start looking for owls. And so independent of any of the Teton-to-Snake stuff in 2013, we started looking for great grays for our research project. But we were really focusing in on those areas that could have been targeted for the Teton-to-Snake area. And so in that first year, we were looking at, we went to 724 different locations across the valley to look for great grays, including some 2-3 times, and just kind of designing the study area in general to see if we could overlap with the future Teton-to-Snake project. And we found a lot of birds. Just in that first year. These are all of the owl detections we got of the different species, from boreal, great gray, great horn, long-eared, pygmy owl, saw-whet owl, and even a barred owl that year, which I will say is only one of a few barred owl detections in the valley. So fast forward, we finished that study up 2015. We looked at over almost 2,000 locations we went to in the middle of the night. And to remind you, this is March and April in the Tetons with feet of snow. All at night, looking at over 742 collective hours to survey for owls across this landscape, found 680 detections of different owls of 7 different species, including almost 160 detections of great grays and 124 detections of boreals, which is what that map is on the right. The great grays are in white and the boreals are in blue. That map on the left are all of the survey locations we did from 2013 to 2015 by going out there in the middle of the night, playing an owl call and listening for that territorial owl to respond. Also combined with this project, we were looking at, okay, well, what does the movement look like? What does habitat selection look like? And how do those detections relate to nest sites? And so in order to answer some of those questions, we started putting transmitters on great grays that we captured so we can track them both manually and with GPS. And I'm not going to get into the details of that. I'm just touching in basically on an overview of what we were doing because it's going to become important here, as you can see, with the Teton-to-Snake fuels reduction project. And then the other big question is, okay, well, if you're going to protect the habitat of an owl, how much habitat do you need to protect? The territories overlap, and how does their space use over time differ, both by nesting status, by sex, and by age? And then, if you're going to protect a nest site, what does that mean? Are you protecting the tree? Are you protecting the stand? Are you protecting the larger area? And so those are things that we were and still are looking to answer from some of our tracking research questions. So to go back, and at the same time, Forest Service, Brieger Teton was looking at the EIS for the Teton-to-Snake fuels reduction project. And so, and as part of that, there are 4 raptor species of concern for Brieger Teton National Forest. So going left to right, we're looking at goshawks, great gray owls, boreal owls, and flammulated owls. And so during this process of when the Forest Service was initially looking for the environmental impact and writing the environmental impact statement, they were calling us because we were doing this work down there. And we started merging the data with the plans. Because the plans had raptor nest protections built in, because those are species of concern, they did consider the data that we had collected at the time and altered some of those potential treatment boundaries based on what our territories were. So for example, in this slide on the right, there's some big forest treatments, and we knew and identified this as an important nest patch for some of those raptor species. And so partly due to our data, that area was excluded from forest treatments. And then also we built in, not me, I wasn't involved at all, but just based on recommendations from our data and from Susan, the timing stipulations were built into when those treatments could occur to protect nesting raptors. So we're already, even before these treatments start, we're starting to see a merge of research and management, which is exactly what you want. And thankfully, we had the luxury of having the data to do that. So in between the draft and EIS and when the final EIS was released, we were still continuing on with our study. And, thanks in part to many funders and foundations and individuals, we were able to continue this beyond what the State Wildlife Grant did and continue. But one of the most important things that's relative to this project is we switched from these night surveys where we skied out at dusk and stayed out all night hooting for owls. We found a better way to do that by using passive acoustic recording devices that we place out, thankfully during the day, which makes it a lot safer and, frankly, more comfortable because you don't have to be skiing out at -20 degrees in the middle of the night. But more importantly, I'm just going to glass over all of the data that went into this. What we found is that they were much more effective. So when we went out at night and we played a call of a great gray owl and the great grays called back, turns out that only about half of the birds were responding. So we were missing half of the birds that were on those territories. Whereas with the passive recorders that we set up for a week, we had almost 100% detection rate of birds that were on territory. So hugely more successful, but then also just more comfortable and safer for our crews. And we can gather more data over a bigger area. So, and not only that, it's not just great grays. We can look at, so, if you've got a forest patch, you might have 4 different territories. One might be a great gray, you might have a goshawk in another, a boreal or a flam in another. And these recorders can simultaneously pick up all of those species, which is awesome because we couldn't do that when we were just playing a great gray call. So essentially we're getting 3 species for the price of 1 during those early periods when we're looking at finding great gray owls, because we put out the recorders in March and April. And at that time, goshawks are also doing their pre-dawn vocalization calls, which you pretty much just get a few calls right as the sun rises when the birds are on territory near their nest sites. Similarly, we can also hear boreal owls on the same recordings. So again, not getting into details and glassing over years worth of research, what we see in goshawks is almost the same thing we saw in great grays, where if you've got territories that are active and even territories that are not active, so the birds are there, but they don't lay eggs, our recorders are still picking them up, as opposed to when you go do the traditional callbacks by playing a call, those callbacks were not picking up about half of those birds again, where the recorders were picking up all of them. So again, much more successful at finding raptors when they're there. And these are, they're large birds, and we know goshawks can be aggressive and vocal, but they're still pretty secretive, and so they can be pretty challenging to survey for. And side note on goshawks and goshawk nests, it just so happens that there happens to be one of the premier goshawk researchers on this phone call. And she's had some amazing data showing that there is a potential, concern with goshawks on the caribou targhee on the west side of the Tetons, potential decline over the years that Susan Patlow was studying birds over there. And she's got some awesome data from disturbed and timber harvested areas that is also germane, looking at almost twice as many occupied nesting areas and successful pairs in undisturbed habitats as disturbed habitats. So laying the groundwork for needing more studies and understanding the effects of forest treatment on raptors. And so we'll talk about that more in a second. But all of this lends itself well to landscape level monitoring with the implementation of the Teton-to-Snake Fuels Reduction Project. And so in collaboration with Brieger Teton, we decided to look at all of the proposed forest treatment areas using those recorders, again, because they're so much more successful, and define occupancy of those treatment areas for their 4 sensitive forest raptors, the boreal owl, great gray owl, northern goshawk, and flammulated owls. And we just talked about flammulated owls, so we've got to get sidetracked a little bit here for a few seconds on flams, because we've just been talking about the other species. So flammulated owls, one of our smallest owl species, also a sensitive species for the Forest Service and the state of Wyoming, but largely because of their unknown status. So really, there was some breeding records in the southwest corner of Wyoming, but generally nothing in Wyoming. And so they were essentially thought to not breed here. Everybody acknowledged that the habitat was here, but because of their lack of presence, they didn't really get much spotlight in the EIS. So also not related to Teton-to-Snake, I got a picture, and Raptor Center got a picture from Nicole Lusky of this little guy from down in the Hoback in 2014, I think it was, or 2015. This is a fledgling flammulated owl. And the only way to have a fledgling flammulated owl is to have a nesting pair of flammulated owls that successfully fledged this guy. So it got us thinking. And then also that fall, a flam came in from to the rehab center from Horse Thief Canyon. It was in a garage, I believe. And so I was thinking to myself, well, maybe, we should look around. And one of the challenges is flammulated owls are almost solely dependent on moths. And as you guys know, moths don't really come out in March and April in the Tetons because there's too much snow. And they're one of our few neotropical migrant owl species. So on the left is a map from some geolocators that some folks put out in California, Utah, and Colorado, showing that those migration corridors in the wintering areas of flammulated owls. And why this is important is because when we're looking for goshawks, great grays, and boreals, we're putting those recorders out during their courtship period, which is well before these birds are back from migration. And so just by the virtue of when we were putting recorders out in our study design, we were missing these birds entirely. So with thanks from, with help from TCD and the Megan Bird Brains Fund and the Community Foundation, we were able to do a couple of years of dedicated flammulated owl surveys across the southern half of the valley. Again, layering on our study area to incorporate the potential Teton-to-Snake areas. And as you can see in the orange and in the yellow, we've got flams all over the place, which is awesome. And to find this species breeding in Jackson Hole in 2016 and 2017 for the first time was, I love that we can add to our body of knowledge like that, even in this day and age. And so what does this mean? So let's get back on the rails here for Teton-to-Snake. Flams are here in extra surveys in a dedicated time period for flams are needed later in the season because of their migratory status. So now we take advantage of the opportunity. We've got the Forest Service and Raptor Center regularly engaging, changing information on a, immediate basis, and incorporating the best and newest information both into management and then also to help direct our research for the coming years. And so we're taking advantage of ongoing long-term studies. We're also taking advantage of this large landscape fuels project to go and merge those into one of a few opportunities to look at multi-species impacts of large-scale forest management on forest raptors, and designed a thoughtful before-after control impacts design study to look at the potential impacts, either positive or negative, from the fuels reduction project to our forest raptors. And so super kudos to those guys, because when you have adaptive management and you add science to that, it's a win-win for everybody, the community, the birds, as well as moving the science forward. So basically, in a nutshell, we're looking at 2 years of pre-treatment monitoring to figure out the occurrence of those forest raptors in those areas. And then 2 years of monitoring post-treatment after the treatments are all completed, to look at potential effects of occurrence of those raptors. So in practicality, what does that look like? It means every spring we sit down with Andy at Brieger Teton. We talk about where the fire crews are, what the weather is going to look like, and we adjust our surveys according to the plan. And we try and get 2 years of surveys in before at least, and that's the green, and then 2 years post. And that changes all the time, because we all know that plans change due to weather, access, COVID, and everything else. And so that's where that continual discussion between partners is really key, and really what makes this unique, makes it possible, and a testament to what's going on in Jackson Hole in our community. So for the past few years, we have amassed over 95,000 hours of recordings. And that's probably a pretty conservative estimate, because I was just going for 1 week per deployment, but we did much more of that. And what that means is just a ridiculous number of hours sitting in the office going through these recordings and verifying the occurrence of those species and the number of calls that are occurring in those areas. And thanks to several folks I see on the call today that are also helping us run through all of those recordings. Thankfully, we've got some analysis software that speeds things up, but it's still very time-intensive process. So what does that look like? Well, let's just take last year, for example. Here's some great gray detections in some of the treatment areas that we looked at. But just because you have an owl calling doesn't necessarily mean anything. So what we need to do is dig deeper into those data and look at how many times those birds are calling. So here they're color-coded, where green, it's just a few calls, up to red, where it's in between at least 100 and 200 calls. So we stopped at the 200. We're like, hey, if there's 200 calls in a week, there's a territory there. And even more so when you've got duets of a male and a female calling together, indicative of those territories. And so that starts to hone us in a little bit so we can define where potential territories are. And so we've done that for great grays. We've done it for boreal owls. We've done that also for goshawks, and now for flammulated owls. And so you could be asking yourself, okay, well, now you've got those data. What does that mean? And what happens when those raptors are in those treatment areas? So I want to provide an example just from last year. And behind Red Top Meadows, we had one of those areas that was had nesting goshawks, had nesting great grays, had nesting boreals, and had nesting flammulated owls. And so what did we do? So we went back and we opened those discussions with the folks at BT and modified the treatments. We protected those nesting habitats, but also really important is the purpose of the Teton-to-Snake fuels reduction is to safeguard our homes and our communities. And so we not only saved those nesting areas, but we still defined an area along the edge of the forest where we could, or not we, I'm not going out and doing that, but Forest Service folks could go out and manually thin and prune and pile and burn those to safeguard the neighborhood. And again, based on the correct timing for all the birds that are nesting there as well. So a great example of using the data in real time to adjust stuff that's on the ground. And this was a pretty significant adjustment because this was a commercial thinning operation that was slated to happen. And so, you know, the next piece of this, and one of the science questions is what is the treatment effects on raptor ecology? And when you think about that, we've got at least 3 different things we need to think about. We need to think about nests, protecting nest sites and nesting habitat, and then also roosts, because most of these are owl species, you know, that we're talking about, roosts and cover, and then also foraging habitat. And each of those has a significantly different interpretation on how you're looking at the data. So let's start with roosts and cover. All, you know, really important for owls, and, you know, very important for great gray owls, for example. There's, you know, owls are weird, and I don't really understand why, but for some reason they decide to leave their nest well before they can fly. So they're running around on the ground a lot. They get mobbed by every other bird that's in the forest, and so they need to find a place where they can hide. And, you know, we see examples of that for adults where they try and get up against, you know, some of these Doug firs, but not only, you know, Doug fir, spruce, aspen, these birds blend into every single tree that they sit next to, but they, you know, generally prefer that the shaded areas for cover. You know, when you talk about nestlings, these guys, again, are running around on the ground for the first few weeks of their life. They can't fly. They need that kind of downed, leaning logs and branches that they can get on and climb up to safety from predators. And also, in case you guys didn't know, all owls face right, and they're only on trees that go up to the right. No, sorry, bad attempt at humor, but just happens to be all of these pictures. And then, you know, what's important around the nest sites and what's important for, you know, post-fledging areas, as some of you may have heard on for goshawks, you know, that protecting those areas where the fledglings leave the nest, they're vulnerable. And here I just wanted to pull up an example from a bird that we put a transmitter on. And this is a female, and you can see, you know, a very tight cluster of locations around the nest site. So that's kind of reflective of this post-fledging area. And I'm going to zoom in on this a little bit. And if you kind of fuzz your eyes a little bit, you can see just south of that housing, there's an area right in here that was thinned back in 1992 and 2005. And the reason I bring that up is, you know, this is anecdotal, but at least for this bird, there was an avoidance of that, even though that forest was thinned a number of years ago. So still providing good habitat for these birds. Sorry, get rid of this. And so, all right, so let's move over to foraging habitat real briefly. So with foraging habitat, this is different. You know, this is less about forest structure for cover for the individuals and for nest sites. It's more about what does the understory look like? What is the forb component and grasses and flowers and soil compaction look like for prey abundance? And how does that affect edges and meadows that these birds typically like to forage at? And the scale that we look at is also different. So instead of looking at that site-specific habitat use for nest sites, we need to look at a much broader view of the landscape. And so just for reference, here's that same female, here's her mate. And you see a much more diffuse pattern across a much larger area. So this is the same time window between these birds within the month after the chicks left the nest. And you can see what we're looking at is much different, and the interpretation of habitat use and landscape use is different. And so how potential forest treatments affect these types of movements are different interpretations. And we're not there yet, but that's kind of what's always in the forefront of my mind when we're doing this stuff. Same patch of habitat, different species. Let's look at great grays for a second. Great grays, you know, they're a little, you know, we need to think about more of that roost versus foraging. And so here we've got, these are data from Catherine's PhD dissertation that she's working on. And the blue are night locations where the birds are foraging, and the yellow are day locations where it's roosting. So you can see specifically down in this southern aspect here, the birds more actively foraging in meadows and moving out of that forest cover. And so what's important during the day may not be the same thing as what's important at night. And so focusing on all aspects of this ecology is important when we're looking at trying to define habitat use and habitat selection relative to these forest treatments. So what do the treatments look like? You guys might be thinking to yourself, I bet you've got a picture in your mind on what the treatments look like. So with some help with the folks from Brieger Teton, they kindly provided me with some pre and post photos of some of these treatments that are ongoing now. And so we've got the hand thinning and burning. So that's when the crews go in and select what's cut, pile it up, and then burn it a year or so later when it's safe. Or a larger scale prescribed fire that I believe is done with a helicopter and with ground crews. This is where I stopped knowing about anything. And so I'll just stop talking about that and show you some pictures. So this is pre-treatment on the left and post-treatment on the right. So you could see, especially in that top picture, some of those dead limbs coming off of that old Doug fir, opening up that understory, getting some of that ground cover a little more open, which may be better for small mammal diversity or access from owls to prey, for example. Here's another one from hand mechanical thinning and burning. So it's not, you know, I had in my mind of like, oh my gosh, the forest is going to be gone. They're just going to clear cut this whole thing. And that's really not what's happening. It's subtle changes to the forest, which makes fire suppression easier. And also, you know, from the literature, has the potential to increase small mammal diversity, which could increase raptor occurrence as well. Again, we'll see. Here's another one. You know, some larger trees are removed, as you can see in the bottom picture. That middle tree in between the leaning one and the one standing up is gone, but still not like drastic changes to the forest structure. Burning has typically been on south-facing slopes, open areas, sagebrush so far. I think that might change a little bit in some of these areas, but so far that's kind of been the habitats that's been targeted. And it's pretty well known that if you have a more heterogeneous landscape with grasses, forbs, and sagebrush, it has a higher small mammal abundance and diversity than just sagebrush. I will say, as somebody on the sage-grouse working group, this is not occupied sage-grouse habitat if you're thinking about that, so don't worry. This is outside of our occupied sage-grouse areas. And so here's another example just from this year, and this is, you know, this is a little not representative because it's immediately after the burning. I think if we were to take pictures there next spring, it would look much different and greener, but you can see a reduction in the sagebrush canopy. Similarly in these pictures, and some aspen stands as well. So again, things I'm curious about are effects on prey, opening up new meadows, opening up more foraging habitat, and what does that look like relative to the birds? So are more birds there? Are more birds occurring there? And are more birds moving there? So I'm just going to share a few anecdotal observations. And I want to start actually with the goshawk on the left. And interesting side note for those of you that love birds, this is a male goshawk on the left that I'm holding and a female goshawk on the right that Roger Smith is holding. And if you didn't know, you could tell the difference between males and females just based on the degree of barring on their chest. So you see the male looks much more white, and obviously a lot smaller, as all raptor males are smaller than their female counterparts. So I'm going to share a couple anecdotal observations from some of these birds that we've been tracking relative to the treatment area. So in this map, we're looking at, that's that same male on the left. Eye, just because it's cool, their eye goes from yellow to crimson red as they age and become more socially dominant. In accipiters, this is an exceptional eye. I can't stop staring at it. But in the map on the right, those pink areas are the areas that were burned this spring. And this male was tagged, I believe, is actually the same week that burning was occurring. So all of these locations occurred after the treatment this spring. And you can see, you know, again, anecdotal, it's just a few locations, but not actively avoiding those areas, which is great to see. Similarly, we had flammulated owl territory just adjacent to those treatment areas. And those white highlighted locations are locations of flammulated owls after the treatments occurred. So even though the treatments occurred, it wasn't necessarily where the nest itself was, but it didn't dissuade the birds from being there this year, which is amazing because, side note, we did flammulated owl surveys across the state this year and did not pick up a single one. The only owls that we picked up were on some of these recorders from Teton-to-Snake and some of the other areas, but all of our callback surveys across the Bighorns, the Winds, the Wyoming Range, the Sierra Madres, the Laramie Range, no owls, as opposed to 2-3 years ago when we did it and we found owls in almost every one of those mountain ranges. But that's a talk for a later date. Okay, so here's an owl that we have data pre-burn and post-burn. So this is pre-burn. These are the locations of the owl, and you can see some locations kind of off to that right, but really nothing in those burn areas. And the red ones aren't very accurate and the green ones are accurate. That's what the color is. But here's post-burn. We've got at least a few locations in those burn areas. So again, you know, this is a few observations in anecdotal, basically just suggesting that there isn't active avoidance relative between the 2 years. And we're not done. We've got a lot more work to do. We're going to continue to monitor territory occupancy with recorders. We're also going to continue to find nest sites as best we can by having the crews out there looking for birds, looking for that pre and post information data. The monitoring of the movements has been adjacent to the Teton-to-Snake objectives, but we want to continue that as best we can. And we'll continue to monitor those movements of birds in and around those treatment areas when it's possible and when we have funding to do so. But really what it comes down to is, you know, this is a really unique situation that I'm super excited about. We've got ongoing long-term studies. We've got an amazing community here with awesome collaboration, amazing coordination, and unparalleled communication between the Forest Service and Teton Raptor and our team that involves real-time data sharing. Like I can find a bird, call up the crew, say, hey, you know, we might want to rethink this forest and then we immediately start talking about it. And we have an investment in both the monitoring and the science, which is awesome. And I can't give Brieger Teton and that crew enough kudos for that and realizing this opportunity to not only advance their project, but also advance the science on this side of the stuff. And we're leveraging a ton of people, this place, and this amazing time we're in. And so with that, I'm going to just say thank you to everybody, including and especially the folks at Brieger Teton National Forest, Andy and Jason and all those guys, and everybody else, and the host of individuals and organizations that have helped fund our ongoing research. And so I'm going to do one last shameless plug. If you liked some of these pictures in this presentation, I encourage you to purchase Steve Mathis's Phantom of the North book with wonderful text written by our very own Catherine Gura, PhD candidate at the University of Wyoming, working with Teton Raptor Center. And so with that, I'm going to wrap it up and see if there's any questions that anyone has.
Thanks, Brian. I've got some questions in chat, and if you wouldn't mind, please, it'd be easier if you send your questions through the chat. Brian, did you set up controls between treated and untreated areas pre and post?
So yes, to some degree. The controls are some of those northern areas that you saw on those maps outside of the Teton-to-Snake area, so along the western edge of the Tetons, that we have been continuing to monitor. And we do continue to monitor all of the occupied territories that we've worked through over the years. But it, strongly within the Teton-to-Snake area, it is the pre-post opportunities that we're looking at.
How about how can you measure changes in raptor community structure post-treatment?
So that's where the looking at the occupancy rates of those birds within those same treatment areas for multiple years after the treatment is completed. So, you know, if and some of those treatments take years to complete. So they'll go do the mechanical cutting, brush pile it up, and it might take a year or two before those piles get burned. And so we wait until those are finally completed. And then, and then we'll look at the occupancy rates of those species that are occurring there prior to that and then after that. So looking at all of those species across all of those years.
Got a related question. Could the presence of birds in the same areas pre and post fire be because of the habits of the birds going back to familiar places? And will 2 years be enough time to see if a shift in behavior?
I would love nothing more to continue this for 10 years post. Given the confines that we have with time and resources, it's what we've got. It's a great question. These birds, as most of you know, raptors are long-lived species and return to nest sites over and over again. And so it's a glimpse. It is the best we can do with the timeframes that we have, but I would love nothing more than to continue looking at this for years after. And you know, we were looking at this for years before. And so hopefully that opportunity will present itself and we can continue.
Are you ever challenged that wildlife has some ability to escape wildfire, or is there data that shows massive loss of life in bird life?
Great question. And I think for me, you know, after seeing these treatments and how they're changing the forest dynamics and changing the cover, it's much, much more catastrophic to have those stand replacement fires like the green Knallfire, where the habitat is lost completely. Changing the forest structure a little bit to safeguard our community, I think is much better than those stand replacement fires when the birds can't be there anymore for, you know, upwards of 100 or 200 years, similar to what we saw up in Yellowstone. And you know, the jury's out on the effects of some of those treatments. So hopefully we can provide more data on that front.
Any idea why flammulateds weren't detected in the rest of Wyoming?
That's the $1,000,000 question. And I do think it has a lot to do with similar declines in migratory birds across the state, across the board. You know, there was a recent article that came out of University of Wyoming, I think last week or 2 weeks ago, talking about climate change as it related to early storms last September, plus all of the wildfires and kind of maybe navigation being off with some of the migrants. We also know that there were large storms down in Texas and south this winter, which, you know, some people escaped by going to the Caribbean, but the birds couldn't do that. And maybe that affected insect populations. And so my guess is it's a combination of those things because we did not see that decline in our other raptors that were not insectivorous or non-migratory.
Yeah. What would you recommend for monitoring future fuels projects on the BTNF and adjacent forests?
For raptors, I feel like we've got a pretty solid combo. Like, I mean, as it was mentioned, longer term monitoring, because these birds are longer lived, I think is important. But then also I think the importance of being able to predict what good habitats are, so we know where to potentially target our surveys. But the beauty about the acoustic recordings is that we can blanket entire large landscapes if we have the detectors built for those species that we're looking for. And so not only can we get raptors with that, you can also get songbirds, woodpeckers, you know, a variety, amphibians, all of it. It's just a matter of building up this technology, which is in its infancy, to be able to monitor all of those species at the same time. And, you know, we're banking all of this data. It's several terabytes of data every year that, you know, now can be used in retrospect if somebody wants to go look at, you know, Clark's nutcrackers or, you know, or woodpeckers in some of these stands too. So just like sightings for eBird are building up our database. Acoustic data is on the cusp of that, and I'm excited to be a part of that kind of push in ecology.
And you're part of it with your Sound Scout recording technology.
Yeah, for those of you that know me, I'm not the kind of guy that sits there and waits for the technology to come to me. If it's not there, we'll make it. And that's what we ended up doing for this and other projects, is developing our own recorders, which have been very successful, and then being able to provide those recorders to other researchers as well.
SoundScoutRecorders.com, folks.
Thanks for the plug, Bernie.
Well, Brian, I really want to thank you for this. This is, this is a fabulous effort of research, and it's just, amazing to me that the Teton Raptor Center has managed to develop such a robust research program along with the education and rehabilitation. And I know of no other rehab centers in the country that have this level of research attached to their programs, and it's utterly invaluable. I figure it's just part of, if you don't have more raptors, you won't have more raptors to treat, and the center will be out of business.
Yeah, I feel privileged not only to be a part of Teton Raptor Center, which, as you say, is an amazing conservation resource for raptors, but just, again, coming back to this community, to having the breadth of folks that are even sitting here and wanting to hear me speak is humbling to me. The caliber of folks that we have here in the community that we have, and hopefully we can continue this, for future generations, and that's what's exciting.
I want to thank everybody for joining us this evening. And if you're on the Bird Club email list, you'll see that we've got a pretty full suite of programs coming up over the next year. And our next one will be Feeding Ecology of Birds with my old birding mentor, Bill Getty. And it should be pretty interesting. So if you're not on the list, just let me know, jhbirds@gmail.com, and I'll put you on the list. But I hope you will continue to join us. And I can't tell you how happy we are to be back semi-live, but online, and able to bring some of these programs to you. So thanks everybody for joining us. Brian, thanks again. Hope to see you all out there.
Thanks everybody for joining tonight, and hope to see you sooner than later.
And don't forget the Raptor Center, the Megabert Rains Wildlife Fund, and especially the Teton County Library Foundation, who makes this all possible for us. And there's some big deal going on. I think we're all supposed to give our money away. So talk to you all later. Thanks again.
Thanks, everybody.